Hello बच्चों, कैसे हो आप लोग? See, in the last few videos, we try to understand anything, right, children? Okay. Newton laws of motion we understood. In a some of the concepts we understand like contact force, free body diagrams and all. In this class, we'll try to understand what is the friction. Okay, different types of friction and what is the friction. So that this is based on this, we're going to solve the problems also. Let us see what is the static friction. Okay, we have friction when body is at rest. We applied a force, that opposing force comes in called static. When the body is in motion, the opposition force acts on the body. Okay, when the body is in motion, when opposing force acts on the body, in that condition, what we call kinetic friction. So in this, we're going to study two parts. One is static friction based on this problem, and the next part we're going to study kinetic friction. Under that, some problems we're going to discuss. See, for IIT JEE, how they're going to ask problems based on the static friction concept we're going to discuss today along with the problem. So theory is very less here. When a force try to move an object for thrust, okay, when a body is just there on a table, when a force try to move an object, okay, there may develop an opposing force parallel to the contact surface. This is the contact surface. The opposing force will develop in parallel to the contact surface. Okay, this force of friction, what we call as a static friction. Right, children? The body is not moving. When a body is at rest position, this word is important. When a body is rest position, even though the force is trying to change the object position, but opposing force is acting. No, that's just both are self-adjusting. The static friction is also called as self-adjusting friction. Right, children? This is what we call static friction. That is represented with the symbol F subscript S. Fs. The maximum static friction is proportional to normal reaction on the body. See, at maximum static friction, let us see the graph. It is clear to you. The friction will try to increase up to some maximum extent. Again, once the body starts moving, no, friction is almost constant. That means this is the static friction at exact point is what we call maximum static friction. Highest static friction is called a maximum static friction, or also called as a limiting friction. Okay, children, the maximum static friction or limiting friction at this peak point. Again, it will start decreasing and it will be constant when it is moving. That is kinetic friction. Right? So suppose maximum static friction is increasing, goes on increasing. As applied force starts increasing, the static friction is also starts increasing. It will reach a maximum point. But one point, what happened? All the irregularities. See, I told you already how friction will cause. Friction will be caused because of irregularities, interlocking of this irregularities between the two contact surfaces. Once this irregularities will going to break, so the two surfaces will almost act like a smooth surfaces. So now they can easily move. That means static up to maximum static friction. No, it will take just a force. It will take on the whatever applied force that will be taken in the form of just breaking this irregularities. Once irregularities are breaked, so this body is almost constantly it is moving. That is constant friction is going to act on the two surfaces. Then it won't increase the friction. Understood, children? So once irregularities will break, that time body just starts to move. No, that point what we call maximum static friction, or this is the highest friction we call. So that highest friction or maximum static friction will be proportional to normal reaction. That is, maximum static friction will be is equals to, children, see, normal reaction will be acting upward direction. That is mu ms what you can call. Okay, mu of m into g. Okay, mu mg. This is nothing but maximum static friction, or weight will acting downward. W is equals to mg is acting downward. This mg is balanced by normal reaction. How many times? What is the coefficient of friction between the two surfaces? That into mg, weight, times the maximum static friction will be dependent. Understood, children? Maximum static friction formula is mu s. This is a static coefficient of static friction, called it as mu s into mg. See, the friction Fs is not proportional to n, but only what is proportional? Maximum static friction will be proportional to n. Sometimes they'll give the questions. Yeah, we'll discuss in the question that question point. See, ms is proportional to normal reaction, or fms, maximum static friction we call. Maximum static friction proportional to mu s of n. Ng also we can write, or we can also write this mg is nothing but n only. No, both are equal. So we can write mu s of n also. Understood, children? Fms we can represent as mu s of n. This is a formula. Weight m into g and frictional force is mu. I hope this is clear, children. Yeah, next the proportionality constant. Here we, instead of removing this proportionality constant, we wrote mu s. No, that mu s is called coefficient of static friction. See, always a static friction. See, up to this point, no, we call it as a static friction. Suppose this is 1, 2, 3, 4, 5 like that. Suppose 6 is the maximum static friction. See, Fs value, this is the maximum static value, and this is Fs value. Fs value is always less than what, children? It is always less than maximum static friction, FMS. FMS, or we can write mu s of L. This is a formula. Understood? FMS is always less than NS. See, if you read only theory, you cannot able to remember this concept. Once you learn this graph, okay, once you learn this graph, up to here, this point is called Fs, and this point exact at the peak point we call maximum static. Again, it decreases and constant, that is kinetic friction. Okay. Let us see the problem. Definitely when you solve the problems any physics, no, then only you'll get a clarity regarding the concept. Let us see the problems. Here, see, the coefficient of static friction between block and the rough horizontal surface is 0.6 Newton and the normal reaction N on the block is 100 Newton. I'll just take the page to explain this question, children. Let us see. Yeah, let us take one while I just take it. So children, what is the given data? I just read out the problem once again. Given the coefficient of static friction between the block and the horizontal surface. Suppose one horizontal surface is there, and that what we kept one block. Okay, children, and that we kept one block. Now, what is the forces acting on it? We need to find out. What is the given the horizontal surface in the figure is 0.6 mu. Yes, coefficient of static friction given as 0.6 is it. See, coefficient of static friction does not have any units. Why, children? Because see, mu s is the ratio of what? It is the ratio of both the friction forces only, frictional force and the normal reaction. That's why it does not depend upon. See, Fms is equals to mu s of N, where N is also force, Fms is also force. So both the forces will cancel. The ratio, what you will get here, mu s is nothing but it is the ratio of Fms by N. So both they are having the Newton and Newton, the both will cancel the unit. So dV is a unitless and diameter, just a constant quantity. Okay. So let us come to the point. Given here, mu s is 0.6 newtons. Understood, children? Mu s is 0.6 newtons, and normal reaction on the block. Normal reaction on the block acting perpendicular, that is given as 100 Newton. Normal reaction on the block is given as 100 Newton. Here, first question, find the maximum static friction acts on the block. So you need to find maximum static friction, right, children? We need to find what? Maximum static friction. So maximum static friction, the formula is Fms is equals to mu s of N, where mu s given as 0.6 and N is given as 100. So multiply 10, this point with 0 cancels, remaining 6 into 10, 60 Newton. This is the maximum static friction. That means I told no graph in the maximum up to where the static friction again consider this point. Fms is 60 Newton. Now, if applied force applied on the body, the force is applied on the body is, what is the applied force? Okay, the first condition, even when the applied force is 0 Newton, okay, when the applied force is equals to 0 Newton, in that condition, what is the then what is the static friction on the block? You need to find Fs. So one thing they try to understand here, when the applied force is less than maximum static friction, okay, when applied force is less than maximum static friction, the body does not move, because the body can move only when you can apply more than this maximum static friction. Okay, children, the body will move or starts to move only when you can able to apply more than 60 Newton. If you apply 0 Newtons and is not applying any force, that time frictional force is also 0 Newtons. Understood, children? The question is very simple, no need of solving anything. When body is at rest, frictional force is not acting on the body. Understood? Next one. This is the first question, and in the second question, second point in that, and third point what they asking is that if the pulling force, that is the applied force on the block is 40 Newtons, when the applied force is how much it is? When it is applied 40 Newtons, so what happened? The maximum frictional force. See, this is again the friction applied force. See, applied force that is 40 newtons. Even though this 40 newtons also, it will be less than the 60 newtons only, right, children? It will be not. It will be less than 60 newtons only. That means what happened in this condition also, body does not move. Okay, it is just self-adjusting. That means the frictional force here is also equal to the applied force only. That is 40 newtons only. Understood, children? That the fourth condition. When the frictional force is okay, when the applied force is 60 newtons, in that condition what happened? You see, applied even this is not greater than 60, it is almost just equals to, right? It is just equal to the 60 newton. That's the body just starts to move. In that condition, the frictional force will be also equals to 60 newtons only. Understood, children? When the bird, we cannot apply more than 60 newtons, up to 60 newton, whatever you apply, the applied force just is equals to frictional force. Okay, when it is less than fms, when it is less than fms, applied force is less than fms, in that condition just applied force is equals to the static friction. That's all. Understood, children, up to here? Next one they given, at what value if body starts moving? A body starts will move when you're going to apply more than 60 newtons. Okay, so this is what the question of this. And from this question, what you observe, the children, up to 60 newtons, whatever force you apply, like 0 newton, 40 newton, 60 newtons, up to here what you applied, no, that is just adjusting. It is what is adjusting, this is self-adjusting. So whatever the irregularities are there, it is use that force to break this irregularities and make it as a smooth, then it starts moving. So up to 60 newtons, just it is using that force to self-adjust. So that is why we call as a frictional force is a self-adjusting force. Understood, children? Self-adjusting friction or self-adjusting force. I hope this is clear, children. Yeah. And go back to our point. This is done. This is also done. This question we done, no? See, I told when maximum static friction we got has a 60 newtons, right, children? Just write here answers. We got maximum static friction by solving, that is 60 newtons. Okay, when you apply 0 newtons, since it is less than 60 newtons, so applied force is a friction also get 0 newtons only. When 20 newtons you apply, 20 newton even though it is less than 60 only, in that condition Fs is got your 20 newtons only. And the third condition, when pulling force is less than 40, it is equals to 40 newton, that means it is also less than maximum static friction. In that condition it must be equals to just applied force. In the last condition also same, it will be equal to 60 newtons only. And what values the body starts moving? When it is greater than 60 newton, then the body will starts moving. So from all this data we can write it is a self-adjusting force. Friction is F of S is a self-adjusting force. Okay, children, this is what this problem. Yeah. Now let us see the questions, important questions based on this concept. Okay. Questions is like this. Among the following self-adjusting forces. So no doubt, children, you can answer this question. Is option A. So many of you guess also already I marked, I think. Okay, this is the answer. Max static friction is a self-adjusting. So we derived with some problem. Next, coefficient of static friction may be. See, children, coefficient of static friction means mu value. So mu value, it will be equals to 0 when the body is completely smooth. Okay, for infinitely smooth bodies, the friction force will be 0. If a body having some irregularity, then coefficient of friction will be not equals to 0. It must be like 0.6, 0.7 like that. Okay, that means so observe these values, it never be less than 0. Okay, coefficient of friction, because ratio of two numbers, it never be less than 0. It will be 0 or it is more than 0 only. So that is, it is less than 1 possible, because 0.6 values or 0.5 may be possible. Greater than 1, that is also possible. 1.2, 1.3, like that value is also possible. For a heavy irregular surfaces, it will be. And for a less irregular surfaces, it will be. And when equal to 1, for complete irregular surfaces, it will be equal to 1 also. That is also possible. So you can write option, it is all the above. Understood, children? The coefficient of friction values, it never be less than 1. So never be less than 0, but it will be less than 1 or greater than 1 or equal to 1 also. And equal to 0 also. Understood? But it is never less than 0. That's all. Next. The static friction may not be produces to the proportional to the normal reaction. That is right. Why? I told you already, maximum static friction will be proportional to the normal reaction. Okay, but not static friction. Static friction will be less than sometimes, it will be more than sometimes, or equal to normal reaction also sometimes, but it will be not proportional. Okay, children, it is not proportional. You can see the graph, no? It is not equally rising. Okay, only maximum static friction will be proportional to L. Okay, right. Next, static friction is a self-adjusting. This is true statement. Static friction is a self-adjusting force. So you can write the third question. Answer will be, you can write, it is option A is false, B is true. Option D you can choose. Okay, right. Okay, one second, children. I think they given maybe option, right? Not must be. Maybe it will be equal. Yes, it will be. Yeah. See, this word is important, children. Maybe, may not be proportional, or maybe proportional they given. That time we can choose our option is correct. If they given must be equal, that time it is wrong. So not this option. Sorry, children. You can choose option A. Both are true. Okay. Yes, next question, fourth one. Maximum static friction depends upon, I don't know, FMS depends upon normal reaction N. Yes, on smooth surface, static friction is, on a smooth surface, children, static friction will be 0. Okay, there is no friction for completely smooth surfaces, so we can take it as 0. Next, if a body is placed on a rough surface, the value of static friction is, in case of rough surface, children, value of static friction will be more than 0. Okay, value of friction will be mu is greater than 0. If it is smooth surface, it is equal to 0. For rough surface, it is greater than 0, 0.6, 0.5, like that it will come. Okay. Next, if a body of mass, okay, see here given. So sixth question, about seventh, a body of mass 20 kg is provided, mass is provided. A body of mass 20 kg placed on a rough surface. What is the when the force of 5 newtons is applied from east direction, then the body remains the same position. The value of frictional force under the direction is, that means like the some block is taken, right, children, of mass is normal 5 newtons. The force acting on this block is 5 newtons, of mass is 20 kg is there. So frictional force will be acting from where? From opposite direction. Fs will be acting in the opposite direction. So to find the Fs, we need to first find maximum static friction. That is Fms is equals to mu s of N, where mu s, coefficient of static friction, they given, children. Second. Yes, children. See the seventh question here. A body of mass 20 kg is placed on a rough surface, right? This is what the given data. And here, at the one point, we need to observe that a body remains in the same position. That means the body is not changing. So body is at the rest position. When a body is at rest position, when it is not moving from its position, then that must be what we call as a static friction only. Understood, children? This is nothing but what we call static friction only. When we are applying towards the east direction, the given here direction is east direction, we are applying force. So that the reaction force, that is what frictional force, acting from the west direction. Understood? When in the east direction we are applying force on the block, the friction will be coming from opposite direction, west direction. And it is less than the start, when block is not moving, means that it is less than static friction. In that condition, whatever applied force is equals to the static force, that is 5 newtons only. Understood, children? Solving is not required, but try to understand this logic. When it's in the same position, body block is not at all moving in the same position, means it is static friction only. In the opposite direction, what we applied for, that will be equal, but direction is opposite. That's all. Next question. When normal reaction is halted, okay, children, the coefficient of friction is what? Normal reaction is halted, so n prime is equals to n by 2. Coefficient of static friction, you know, coefficient of static friction is equals to what, children? The formula. So right here, let us see FMS formula. You can also somewhere we write. So coefficient of static friction formula, FMS is equals to mu s of n actually. This is a formula where n mu is given by fms by, okay, fms divided by n actually. When fms is constant, imagine when n is doubled, okay, when n is halved they given. So in place of n, just put fms by n by 2. Okay, what will happen children when you put n by 2? It becomes 2 by n, it will happen, right? So what happened coefficient of friction in that condition? You can see, no, the 8th question, it is unchanged. So here also, I think just I try to solve, but it's no need of solving because normal coefficient of friction is the property of a body. Suppose you take an iron material, have some coefficient of friction. Suppose you will take a copper material, it will have some coefficient of friction. So it is depend upon material of the body, but it is not depending on how much mass and what is the normal reaction. It won't depend. Okay, if normal reaction is doubled or tripled, the coefficient of friction must be constant only. So on that basis, you can answer it is unchanged. Understood children why it is unchanged? Okay, so no need of solving all this stuff. Directly you can write it is unchanged. Yeah. 9th question. Two bodies of different masses are dropped simultaneously from the same height. If air friction acting on them is directly proportional to the square of their mass, then okay. This question will take a little space. I'll just use the screen, children. See what is given. Two blocks are there. Okay, what is the question? I'll just read from this. Two bodies of different masses. Okay, this is a small mass. Imagine this is a mass, small mass, and this is a capital, big mass. Okay, two masses are there of different masses are dropped from the same height simultaneously from the same height. If air friction acting on them is, what is the friction? The friction is directly proportional to square of their, friction is directly proportional to square of their mass. F is proportional to m square. Okay children, F is proportional to m square. In that condition, what is the acceleration they're asking? Alright children, I think what is asking there? The square of their mass. Then okay, which mass will reach the ground earlier? They're asking. So you need to calculate here acceleration, children. So acceleration is given by children. It is m into a g minus of a actually. Okay, sorry, force is equals to, actually net force acting on the body is m into g minus a, or we can write f. Okay, here because of the applied force it is coming, right children? So I can take f. See, this is just clear this neatly. See, what is given here children? Blue blasts. Okay, imagine two masses are falling. When it is falling, the because of gravity force, that is what we call mass of the body is acting downwards, and the normal reaction, that is what because of air resistance, the frictional force is acting in the upward direction. Okay children, and in the second pass also, mass and gravity, okay, that's acting downwards. So to balance this, the frictional forces acting in the upward direction. This is what the given data. For first block, you write the free body diagram. Let us take M1 and this is M2, or capital M1 you can use your wish. So first block, because it is falling down, so M is greater. So M1 of G is minus of F is equals to mass times of acceleration. Okay, that much time it will coming down. Similarly, for second block, you can write M2 of G minus of F is equals to M2 of A. This is what the condition, right children? And in the question what they given, this frictional force is proportional to square of the mass they given. Okay, frictional force is proportional to square of the mass. So here we can write it is F is, in place of F I can write M square is equals to M1 of A. Here also M2 of G minus F square is nothing but M2 square. Okay, that's M1 means M1, M2 square is equals to M2 of A. Here our intention is to find the acceleration, right children? Let us divide entire equation with M. So what you will get? G minus of M1, because one M1 can cancel, you will get A. So acceleration is A is equals to G minus of M1. Here also you will get, if you divide with M2, what you will get? G minus of M2 is equals to A. Alright children? Now see, Here, let us take, for example, I'll take if M1 is equals to smaller body, that is 2 kgs. Let us take M2 is equals to bigger body, 4 kgs. Okay, just for the sake of example to clear your doubt, kgm taken. Now, applying this formula, what you will get acceleration. Right, children? Let us take 10 minus 2, what you will get, children? 10 minus 2, acceleration is 10 minus 2. Similarly, here A1 for the smaller body, and for bigger body, what is acceleration? AMG is 10 minus of M2 I'm taken as 4 kg. So I'll get over here only 6 meters per second square. So because of lighter body, what I'll get here, smaller body, it is 8 meters per second square. That means what we can conclude here is that, children, the heavier body will take more time because it's less acceleration. So that it will take more time. Right, children? It will take more time to reach the ground. But it will, because of more acceleration, what will happen? It will take less time. Okay, it will take less time to reach the ground. Understood, children, this point, everyone? So here from this question, what you got, conclude that lighter body will reach us the ground earlier. Okay, children, the lighter body will reach us the ground earlier. So for this question, answer we can write it is option A. Okay, I'll just come back to there. This question. Okay, see the ninth question here. Which body will reach us the ground earlier? According to we solved, no, children. If it is proportional to m square, lighter body will reach us the ground earlier. So ninth question, you can choose it is option A. 1 second. Okay, ninth question, it is option A. Clear, children? I hope this is clear to you. Okay, let us say 10th question. A cycle is fitted with small brakes. Okay, some cycle is there. Your brake pads will be there, no, to stop the vehicle whenever something obstruction will come. The brake pads will touches the rim of the cycle so that it is going to stop. If that in one cycle they taken very small brake pads, in others bicycle they taken the area of this brake pad will be large, like this they taken. So in the both the condition, okay, children, for the both the conditions, what will happen? The cycle will take, so small brakes will be coming to stop first, the one which is more effective. Okay, which is more effective, they're asking. Since one thing you need to remember, then you can only answer this question, that the frictional force, children, F of S, the frictional force, it does not depend upon area of contact. It will be independent of area of contact. How much area is in contact with other surface does not matter. It only depends upon how much harder you're going to press the two surfaces, or it depends upon nature of the surface itself. It won't be depend upon how much area is in contact with another body. So that definitely this question, see, whether it has the small brakes or the larger brakes also, both will come to stop when you apply the brakes at the same time only. Okay, whether you apply small brakes or the larger brakes. So both will be equally effective. Well, then what is the difference is that one thing, it will be because of less smaller area, it will be damaged first, and it will be efficiency will be more for this larger brakes. That's it. That is why we choose the bigger brakes for efficiency, not because of which will come to stop first or which will come to stop next. That is not a depend upon area. Okay, friction will be independent on area of contact. So remember this point. Okay, see the next question, children. The coefficient of friction, coefficient of static friction has no units. Yes, children, I think you can guess this answer. Remember the formula. If ms, maximum static friction, is given by mu s of n, right, children? Where mu s, this is the coefficient of static friction, is equals to f ms by n, where f ms is what, children? It is a Newton, and again Newton, normal force is also force, that is also Newton. So both the units will cancel out. So does not have any units. So does not. That's why we can conclude that it have no units. Understood, children? Coefficient of static friction have no, not only static friction. Coefficient means it is the ratio of two similar factors, so that definitely does not have any units. Next, value of coefficient of static friction, it is greater than or equal to 0. That is true. Okay, so okay, that is also True statement, right children? So what we can write this answer then? See, coefficient of static friction, mu value is equal. Mu value is always greater than or equal to 0. That is true. So both statements are true, but it's not a correct explanation for this. So explanation is what? Then I have to give the formula ratio of common terms will be equal like a derivative mu. But they're not given that. So statements are correct, but the reason for this, it is not a correct valid reason. So we can write it is option B. Understood children? For this question, this is the answer. Somewhere you chosen this is not, this is the correct answer. Right children? The first question answer is this. The second question. See, the static friction is self-adjusting force. I think no doubt you can able to answer this question, right? Okay. Good children. You are trying thinking answer. Very good. The static friction is a self-adjusting force. That is right. Okay, we solved the problem. No, up to maximum static friction, whatever the applied force, just adjusting itself to break the irregularities. Two surfaces will be contact with some irregularities up to maximum static friction. That means limiting friction of this we applied. That will be just adjusting itself to break this irregularities. That is why we call this the self-adjusting force. Okay, the magnitude of static friction is less than the applied force. Magnitude of static friction is less than the applied force they given. Okay, that's right children? See, it is not less than. See, it will be equal when it is less than static friction. So maximum static friction. Suppose applied force is less than maximum static friction. That time it is applied force will be completely equal, not less than. If they given the word less than, so that is wrong. The statement is wrong then. Okay, only the statement is true. So see the answer. Okay, children. Then frictional force is what children? It is a definitely it is a contact force, right? When the two surfaces are in contact, like two solid surfaces in contact, then only the what we call the static friction will arise. So that frictional force is the static friction. That is true. And also it is a electromagnetic force also. Why electromagnetic force? Because electromagnetic force, except gravitational force, all comes under electromagnetic force only, almost like tension force, because there are interaction between the charges will be taking place. Like we call cohesive force, if the two bodies, like upper body and down, what is the contact body, they have the same material, then we can see cohesive forces. Also different bodies, we can see adhesive forces. All this because of the charges, plus charge, negative charge, attraction or repulsion between the charges will be taking place. That is what we call normally friction only. Okay, so this is also correct. So for this question, we can write option A and C are the correct. Definitely it is not a gravitation, it is not a weak force. Okay children, it is option A and C, electromagnetic and contact force. Next. Force of friction may oppose or supports the motion of the body. That is true children. Friction may opposes and supports the motion of the body. Right, that is right. But it will always opposes relative motion. Remember in the last video also I told, it will always opposes relative motion but not motion. Okay, so if they given only motion, it will opposes and supports also. That is true. The force of friction opposes the relative motion between the two bodies, two surfaces which are in contact. Right? So the fourth question, you can write children, it is option A. So right, because can observe the statement, this is correct, and force opposes the relative motion between the two surfaces are in contact. So relative motion. So both the statements are true. So you can write option A. They're not given, it is reason and assertion type. So both statements are true. Option A is correct. Yeah. Next, see this question. Important question actually. Next is okay. First question here given that children, a body of mass 2 kg, a force 10 newtons. Okay, this is a mass, this is a force applied on a body. When the coefficient of friction is, so mu value given, okay, mu is 0.8. The maximum static friction is what? FMS. Maximum static formula is what children? FMS is equals to mu S of N, normal reaction. So here not given any normal reaction. That means when body is there, a normal reaction is acting upward direction. To balance this normal reaction, M is acting downward. That means normal reaction will be is equals to just M into G only. So instead of N, we can write it as M into G. Right, children? We can write it as a M into G. So now what we can take, that is equals to mu S given as 0.8. Okay, and M value, mass value, how much they given? Yeah, mass is given as 2 kgs and G value they assume you to take as a 10. So 8 we can write as 0.88 by 10. So this point and the 10 will cancel. So 8 into 2 remaining. 8 2s are 16 newtons. This is your answer. Maximum static friction in this condition it is 16 newtons. Right, children? I hope everyone clear this question. So if any numerical changes are like this questions are there, I hope you definitely answer. Sure? Right. Next question, see. The direction of frictional force with respect to plane of contact. When two bodies are in relative motion, they're asking. See, the body is there like this. Direction of frictional force is always parallel. Okay. Fs. Frictional force is a parallel component of force. It will always act parallel to the contact surface. Understood, children? Suppose they will ask normal. Normal means it will always perpendicular. Friction is always parallel. Okay, no doubt you can answer that. Next. So one thing you need to remember, only this friction will arise when you apply the force. Okay, when applied force is not there, the friction and normal won't come. Okay, normal will come, but the frictional force won't come. When you start applying force, that time it will act in the opposite direction. When body is at rest, where applied force is not there, definitely frictional force never act on that. Okay, right. See, next question. A body is just on a rough surface. This is on a rusting earth. This imagine what should be given? Rusting, that is not moving. On a rough surface, a coefficient of friction. Then what is the static friction is they're asking. See, here they're not given any applied force. Here no applied force. Since no applied force, the friction will also no friction. Okay, the friction is also absent. Understood, children? If something we applied, then only opposition will come. If we just close our mouth, how can the enemies will scold you? Right, children? If you just do some opposition, then only they will do opposition for you. If you do tell something, if you keep quiet, how can they oppose? Like this here only. Here no applied force, definitely no friction only. Understood, children? Applied force is not there, frictional force is also not. So it can be 0. We can choose here option without need of any solving any whatever may be the friction. Okay, right. Two masses M1 and M2 are falling from the same height and the just a second are falling from the same height when the same air resistance acts on them. Okay, some air resistance will be acting on them. Which will move with the some acceleration they given. See, in the last like this 1/9 problem we solved, the given friction is proportional to mass square of the mass, but here not given like that. Here given just two bodies. If M1 is greater than M2, so definitely what will happen, children? The more mass body will come ground earlier. Okay. So you know no formula. Acceleration is equals to what, children? G minus of M almost it will come. Okay. Which will have, sorry, this is the formula not wrong, children. This is for only last option. Last question they given. Okay, which will have more mass that will be reached the ground earlier. So M1 is more, so definitely for 8th one, answer is B. Okay, here given M1 has more acceleration means it will reach the ground earlier, and M1 has more velocity and striking the ground, definitely. So all the above are approximate, so you can choose all the above option here. Okay, the next question, children. If the normal force is doubled, okay, if normal force is doubled, limiting frictional force is maintained at the same value, then coefficient of friction is. See, in the last problem also I told you, the coefficient of friction value, it is an internal property. It is what, children? It is a internal property of a body. It does not depend upon external forces. Whether you apply normal reaction is doubled or tripled, or limiting friction is doubled or tripled, it does not matter. It will be a internal property, like how your color. Okay, So if you run with how much speed also, or if you carry how much load also, your color never changes, right children? Because that is the internal property of your body. So like that here also, coefficient of friction is an internal property. It does not depend upon anything. So it is remains constant only. I hope this is clear to you, right children? Yes. Yeah. Next question here given, the limiting friction between the two bodies. Okay. The limiting friction between two bodies in contact is independent of their asking. Okay, it will be not depend asking children, they are independent of their asking. Okay, so 10th question, see, normal reaction between the two surfaces. It will be independent on what children? Normal reaction between the two surfaces. Nature of the surfaces in contact, it will depend. Area of the surfaces in contact, it will depend. Okay, and all the above we cannot choose. So you can choose option C. Okay, so let us see the next some questions, children. Paragraph type question given here. The coefficient of static friction between the block and the horizontal surface is coefficient of static friction. Okay, coefficient of static friction between block and the horizontal surface, that is mu s given as 1.5, and the normal reaction on the block. This is the n value and this is the mu s value given. First, you need to find maximum static friction. What you need to find, children? Maximum static friction given by mu s of n. Okay, mu s is 1.5 and the n value is 18. So simplify this, children. This point and this 0 will cancel. So it is 15 into 8. 15 8 how much will come? 120 newtons. Right, children? So this is the answer A. For first question, it is option A. And the second question, see, pulling force of on the block, 0 newtons is applied. See, 0 newtons means we are not applied any force on the block. Some block is resting on the table. If no applied force, frictional force is also not there. So it is just option D. Without solving, it is option D, because no applied force, no friction force. It will be 0 only. Next, a pulling force and the block 40 newtons is applied. Then what is the static friction in the block? One thing you need to understand here, when the applied force is 40 newtons, this will be greater or less than Fms. You need to check. See, applied force here, it is this 40 newtons will be less than 120 newtons. What we got to maximum static friction. When the blocks start to move, when we are going to apply more than 120 newton, that is maximum static friction is 120. If you apply more than this, then only block will start to move. Or we can apply less than, then this applied pulling force must be is equals to the static friction. That's all. Okay, which is a less than that coefficient of friction, that time pulling force just will is equals to maximum static friction. So we can write here it is just, that is the 40 newtons. Okay, so option is there. Next, a pulling force is 80 newtons. I think this question no need of solving. You can only understand, no, it will be less than or greater than 120. You need to check. Definitely it will be less than 120. So if it is a less than 120, pulling force just is equals to static friction, that is 80 newtons. Understood, children? So answer is this. Okay. Answer A. If the pulling force on the block is 120 newton, then the static friction is, even though it is not greater, just it will be equal only. When it is equal, that time the pulling force just is equals to static friction. So this is also 120 newton. Then what values of F the body starts moving? Definitely, when you're going to apply more than or greater than 120 newton, then body starts moving. So before what you apply to all this force, just the body goes for adjusting itself to break the irregularities and try to come out from the irregularities. Suppose the irregularities means what, children, like the humps. Inside one more humps of the second body, just locked like how key and lock will locked. So when you going to apply, try to move this block, okay, that time this irregularities will try to break. Okay, we applied force is adjusting itself to break this irregularity. That is what we call self-adjusting. Friction forces, static friction is self-adjusting force. I hope this concept is clear. समझना है children, सबको समझना है? Yes. Let us come to some more problems. Yeah. See question clearly here. A block of mass, right children, what is the given here actually? A block of mass 1 kg, this is the mass is given, it placed on a truck with accelerated with an acceleration of the truck is given. The coefficient of static friction between the block and the truck, the mu value is given, and the frictional force acting on the block. What is the frictional force acting on the block you need to calculate. Clear children, what you need to calculate? Yes. So to calculate this, what you need to find children? Say all the data is given. So frictional force just will be is equals to mass into acceleration, right children? Frictional force is equals to mass into acceleration, where mass is given as 1 kg and acceleration is 3 newtons. So 3 ones are 3, so it is just 3 newtons. Okay, this is the answer. Okay children, I hope this question is clear to you. Yes. Okay. So that means applied force is equals to maximum. Why I take an MS form means because you just check whether maximum static friction mu ms. Okay, formula is mu m into g. No, so mu is what children? Mu is 0.6. 0.6 mass is 1 kg. Let us take g is 10. So 0.6, this point and this is cancelled. You will get 6 Newton. So maximum static you will get a 6 Newton. That 6 newtons your applied force 3 newtons is less than, so that time it just will be equal to applied force only. So like that only we are going to take this children. Okay. Next question. A block of mass 1 kg lies on a horizontal surface on the truck. The coefficient of static friction between the block and the truck, again they given mu and the mass value given, acceleration of the truck is given. Okay, acceleration is 5 meters per second. The force of friction on the block is force of friction acting on the block you're going to calculate here. Alright children, so let us find second children. Okay, again see acceleration is 5 meters per second square. It will be less than that, so F is equals to what you'll get, mass into acceleration. Mass is 1 kg, acceleration is 5. So 5 ones are 5. So 5 newtons. Okay. So option A. Understood children? Just you apply F is equals to MA formula. So frictional force will be is equals to applied force only. Mass into acceleration in this two condition, because it is less than static friction. No, that's why. Next one. When next question, see children here, a body of mass. Yes, just a second. Given here, a body of mass 36 kilometers per hour on a horizontal surface having a velocity or coefficient of friction is 0.2, traveling at a distance before it is coming to rest, they given. Right children, this is what the given data. From this, see, velocity given, just the velocity kilometer per hour is there, so they just convert this 36 into 5 by 18, we convert to meters per second. 18 ones are 18 twos are, so you will get is 2 into 5, it is 10. Okay children, 10 meters per second will come velocity. So velocity is there and coefficient of friction is there, and before coming to rest, that means find this is the initial velocity of the body, and before coming to rest means matlab what children, final velocity will be 0. Understood no? When before coming to rest means when body come to rest, its final velocity becomes 0. Initial velocity is there, and from this coefficient of friction you need to calculate the acceleration. Then you can easily solve distance traveled by the body. So let us find acceleration. How to calculate acceleration children in this condition? See, acceleration is equals to actually the formula, remember, mu into g. Okay children, acceleration formula is mu into g. Okay, where mu is how much children, given as 0.2 newtons and the g value is 10, imagine. So 0 and point will cancel, so you will get acceleration is 2 meters per second. Okay, so you will get acceleration. Now find the value, that is v square minus u square is equals to 2as. This is a formula where v square is completely 0. Okay, this is 0. So what you will get, u square, children? Now u square is equals to minus of u square is equals to 2 into acceleration you got as 2 and the displacement you need to calculate. Okay, sorry, initial velocity is also there. What is initial velocity there, children? It is 10 square, right? So initial velocity 10 square is 100 minus is there is equals to 2 2s are 4 into s. So 4s is there. So you want to find the s, right? So s is equals to 100 by 400 by 4 gives you 25 meters, right, children? So this question answer is 25. So this is the answer. Option D is the correct answer. Clear, children? Why answer D? I hope this is clear. First, here you need to find out acceleration, children, is mu into mg, because by f is equals to ma, here as a mu s of mu, cancels, you'll get a is equals to mu g only. So 0.2 into 10, 0.2 10 you can multiply, you'll get 2 only. So acceleration is 2. Substitute the 2 in this formula. V square minus u square equals to 2as. Okay, this is equals to 2as. In the place of a and in the place of s, you can substitute and fill the solid calculate. Okay. Next question. A horizontal force of 150 newtons produces an acceleration of this in a body placed in a horizontal surface. A horizontal force of 200 produces an acceleration 3 meters per second square. Then the body, mass of the body and the coefficient of the body you need to calculate. So definitely your place is not sufficient. I'll take some on the screen to solve this. Okay. Let us take this screen to solve. See, what is the given, children? A block is there. When block is moving, the applied force is 150 Newton. When you're going to apply 150 Newton, body moves with an acceleration of 2 meter per second square. First condition. In the second condition given, when you apply the force of 200 Newton, okay, same block, okay, same friction. When you apply 200 Newton, body will move with the acceleration of 3 meter per second square. This is the condition. Two cases are given. Case 1, case 2. In that condition, friction will be same, right? The coefficient of friction acting on the body will be same. And what is the same mass of the block also same. Only we are applying force on different forces, that's all. So here you need to calculate mass of the body first and coefficient of friction later. Let us see. A block is there, friction will be acting opposite, right, children? When you suppose block is there on a table of mass m, when you apply the force, the friction will be acting opposite. How much friction and a balanced force will be moved with some acceleration. This is the condition. So write the Newton's law. Net force, difference of the two forces gives you F minus F is equals to mass into acceleration, right, children? F minus F is equals to, let us take m1, this is m1, no, m only, because 2 mass is there. Mass into acceleration. So F here applied is 150 Newton minus of F is equals to m, mass of the block we need to calculate, and acceleration is 2. I'll write to the front, 2m. Understood? Let us take similarly write for the second. Here also same, in a place of F it is 200 minus of frictional force is equals to mass, acceleration is 3 and mass is m. Okay, these are the two conditions. Let us solve these two equations. Let us take this as equation 1 and equation 2. Write this equation 1 here. 150 minus of F is equals to 2m is there. Let us do minus equation 1. Okay, equation 2 minus 1 I'll do. Okay, if I do 2 equation 2 minus 1, this sign became minus, this became plus, this is became minus. So 150 minus 200 minus 150 gives you 50. F minus F plus F, both will cancel out, again 0 is equals to this side 3m minus of 2m gives you F. So that what you will get, children? Mass of the block is 50 kgs. Understood? Mass of the block is 50 kgs. Now apply this mass in one of the equation, then you get the frictional force. So let us take frictional force is equals to 150. So F will come this side, 2m will go that side, becomes a 2m. So 150 minus of 2 into mass is 50 kgs, right? So simplify this, 150 minus of 100, so that you will get frictional force is also 50. Okay, 50 newtons. Understood, children? Frictional force, how much you got? It is 50 Newton. But what you need to find? Coefficient of the friction, not frictional force. So F is equals to 50 Newton. In place of F, I can write mu into M into G is equals to 50 Newton. Right, children? Mu mg is a 50. What I need to find? Only mu. So mg will send it down. So mu is equals to 50 by mg will come. Okay, mu is equals to 50 by mg. So mu is equals to 50 by mass of the block. For first condition, I'm taking mass of the block. How much it is? 50, and g is the 10. So 50 50 cancel. 1 by 10 is there. So 1 by 10 gives me what value? 0.1. Okay, this does not have any unit. Understood, children? Okay, this is what the solution of this question. Okay, let us check the values. They are asking you to find the coefficient of friction. That is 0.1. No unit for this. 0.1 you got. And the mass of the blast they are asking, that is m is equals to 50 kg you got. Okay, this is the two values you need to find from this question. I hope this is clear. Let us see answers. One second. Yeah, here. So 20th question, see 50 kg and 0.1 Newton. I hope this is option A. Okay, children, what we got? Option A. Just check. Okay. 20th question, answer is A. 50 new mass is m is 50, and this is frictional force. We got this is answer. Okay. I hope 20th question is clear to everyone. Right, children? Let us calculate 21st question. See again, a block of mass 100 newtons is pushed by a force of F. This is a weight is given, not mass and all. Weight of the block is given and force is given. The horizontal rough surface, plane surface moves in acceleration. So acceleration is given 1 meter, and when force is doubled, okay, when a force is doubled, the acceleration becomes A prime. Acceleration becomes 1 meter to 10 meter. Then coefficient of friction is what we need to calculate. Okay, definitely we did not able to solve here. We'll take one slide. Okay. See, 21st question, I hope. Question. See, what is the given, children? A block is there, right? A block is there. Given data that we apply the force on this block, friction will be acting from opposite direction. Weight of the block is acting downward direction, that is given as 100 Newton, and the normal reaction to balance this is acting upward direction. And to balance this applied force and the frictional force, even though it is more than a frictional force, so that the block is moving with some acceleration. Initial condition it is 1 meters per second square, it is moving. When force is doubled, okay, this is the second condition. When a force is going to 2F, friction is same only. When applied force is doubled, that time, okay, weight is same, normal reaction is also coming same. When force is doubled, body moves with an acceleration. How much? They are given 10 meters per second square. This is what a given data. Alright, children? Okay. From this, you need to calculate the coefficient of friction of the body. Coefficient of friction of the body you need to calculate. Let us see how to calculate this. Okay. First, apply the free body diagram of the first condition. First condition, what you will use? F minus F is equals to mass into acceleration, or you take direct. Okay, mass into acceleration time. F minus F is equal, that many times the body will move forward direction. Right, children? This is a condition 1. So F is what? Okay. Second, for this equation you write this 2F minus of F is equals to mass into acceleration. This is A1, first acceleration. This is the second acceleration. Right, children? Okay. From this, first you need to calculate mass, because mass of the body is not given, only weight is given. So you know weight is equals to what, children? M into G. Understood? Weight is 100 newtons, G will be 10. So 100 by 10, what you will get? It is 10 kgs. Right, children? We can write this as W, we want mass. Mass is equals to W by G. I can write W is 100, G is 10. So what I'll get? 10 ones are 10. So I'll get mass is 10 kgs. Okay, use this mass. Mass of the block is same both the condition. So F minus of F is equals to 10 kgs into acceleration. First condition it is 1. In the second condition, 2F minus of F is equals to mass is how much, children? 10 kgs, and acceleration here it is 10. Okay, this is the condition. Now, so use the two equations. Okay, in place of F, you substitute here and you will get the answer. Okay, let us substitute and see. Here, F is equals, just find here F is equals to, this is 10 plus F. I can write, children, F I am taking this side, 10 plus frictional force. Substitute here. In place of F, I am substituting that 10 plus of F minus of F is equals to 10 times 100. Right, children? So this is 2 times 20 plus 2F minus of F gives me F is equals to 100. Okay, 2 into F, 2F, no? 2F minus this F gives me F. Okay, or we can write F is equals to 100 minus 20 gives me out 18 Newton. Okay, so frictional force will be 80. But what is the formula of frictional? We not find frictional. We need to find coefficient of friction. So frictional force is 80. We can write mu mg. Right, children? Frictional force is nothing but mu mg. That is equals to 80. So what we need to find? Only mu. So 80 by mg. Understood, children? 80 by m into g. So m into g is nothing but weight only. Weight directly given. So 80 by weight is 100. So 0 0 mar gaya. What left? 8 by 10. That is nothing but 0.8. Understood? This answer is 0.8. There is no any unit for this. So only 0.8 we can write. I hope this problem is clear, children. Right? समझना है सबको? I hope. Right? Next question. Say last question here, 22nd. Two trolleys of mass m and 3m are connected by a string. They are compressed and released. They move off in opposite direction and comes to rest after covering a distance s1 and s2 respectively. Assuming the coefficient of friction is uniform, then the ratio of distances is, you need to calculate. Okay, children, this is what the condition of this. Okay, I'll just analyze the problem first for you. See, given here two trolleys. Okay, two trolleys are given. They are connected with this mass is also given. This is the mass m and this is the triple the mass of that 3m is given. So both are connected with what? They are connected with some spring they connected. Okay, when you apply the force, both are first what happened when you apply a force, both will compress first and then, okay, from both end apply, imagine force they applied, both they compress first like this. Okay, come to closure and again they displaces with the distances of s1 and s2. Okay, this is what the condition. Okay, both the trolleys will displaces. This is the condition s1 and s2 given. So now in this condition you need to, so when they go like this and they'll coming to finally they come to rest. Okay, final velocity will be 0 because after compression, after elongation, they'll come this maximum position and they're coming to stop. This also, it will come to extreme position and it will come to stop. Okay, understood? No question. First, two blocks are there connected with some string. When we apply the force, both will compress first. Okay, like this, both will compress, again come back and stay in their positions. Now, how much displacement of the bodies we need to calculate? The ratio of displacement, because this is a 3 mass, this is 1 mass, so that which will move more distance, which will cover less distance, we need to calculate. Okay, children? Okay. See, for a first trolley, let us take for first trolley. For a first trolley, what we can take? V square minus U square is equals to 2 into A into S. Imagine, this is the second equation of motion, where U is equals to V. Understood, children? It is equals to V1. Let us take this. How much initial velocity of this is? Let us take V1 I am taken. So I'll get V1 square, because in going opposite direction, this minus sign will come, minus becomes plus. So V1 square is equals to 2 into acceleration. I told already, acceleration is nothing but mu into g. Understood? Matlab acceleration means what? Mu into g. Up substitute here. Mu g into s. Acceleration given as mu g into s. So that let us take this s1, body move. So s1 is equals to v1 square by 2 into mu g. Let us put this as equation 1. Similarly, let us find for trolley 2. Second trolley, what will happen? V square, same formula. V square minus U square is equals to 2 mu into g into s, because instead of 2 as I'm writing 2a in place of a, mu g into s. Now this final velocity, however, this is also 0 only. So initial velocity, let us take here, velocity will be v. So v is equals to, children, what we'll get, let us take, this is v1, no, this is I'm taking as v2. So v2 is equals to, or v2 square is equals to 2 into mu into g into s1 will get, sorry, s2. Okay, so s2 is equals to what, children? Now v2 square by 2 mu into g. Understood? S1 and S2 you are clear now, children? And masses. Okay, let us see about masses. So now let us take, we need to find the sense ratio only, so that let us take S1 by S2. S1 I can take it as V1 square by 2 mu G into V2. V2 S2 is there down, so take the reciprocal of this term. So what we'll get, 2 mu into G divided by V2 square I got. Alright, children, this is what I'll get. Now see this total factor 2 mg, here also 2 mg, both will be same, so they will cancel. So what is the left, children? I'll get v1 square by v2 square is there, but you don't know v1 and v2, they're not provided any v1 and v2. In terms of mass you need to take this. So you know the second law of motion, that is momentum. P1 is equals to O2. Momentum will be conserved in the inequation. So m1 v1 is equals to m2 v2 we can write. Okay, so m1 v1, so I want v1 and v2, take this one side. So what is left is m2 by m1, just cross multiply here. So m2 v2 will come down, m2 will come this side, that's all. So now substitute in place of v1 and v2, I can write m2 and m1. So what I'll get, children? S1 by S2 is equals to v1 by v2 whole square. I can write r in place of v1 and v2, I can take it as m2 by m1 whole square. Understood? So m2 by m1, m2 is how much, children? It is 3m, and m1 is how much, children? It is m. Whole square is there, put whole square. Now inside m and m is common, so that will margaya. So what is left now? S1 by S2 is equals to 3 square by 1 square. 3 square is 9, 1 square is 1. Understood? So ratio of displacement traveled by the two bodies of different masses will be in the ratio 9:1. That means if the body free mass, it will move 1 meter distance, means this will move off a 9 meter distance. Like that will be the ratio of distance traveled by the two blocks when they connected with the some string. Okay, I hope this is clear, children, this problem. Any doubts in this? Just you discuss. Once you analyze the problem once at 5, definitely you're going to understand that. So this question answer is 9:1, option D. Right, children? You can write. This is the option. Option 9:1. Right. 23rd question. Just to see. Yeah, 23rd question given. A block of mass 20 kg is placed on a rough horizontal surface. Okay. And the force of 12 newtons is applied. The coefficient of friction is given. What is the frictional force acting on the block you need to calculate? Very simple question, right, children? I think you can able to solve this question. Okay, just a second. Block is there, is kept on the table. Apply, this is a 20 kgs block. Okay, this is a mass of 20 kg. When applying a force of 12 newtons is applied, and the frictional coefficient of friction on the block is 0.1. Okay, what is the frictional force you need to calculate? So frictional force is given by the formula mu mg. Right, children? Frictional force is given by the formula, it is mu mg, where mu is what, children? Mu is given how much, children? 0.1 into mass is 20 kgs into g is 10. Okay, 0.1 and 10 will margaya. So what will have only 20. So frictional force you got as 20 newtons. Understood, children? This is the answer. I hope these questions are clear to you. Okay, fine. Okay, children, thanks for watching. And all these questions, this is student has, try to solve it. If not, wait for next video, we'll discuss in that. Okay, thank you all, children. Have a nice day. And keep watching these videos and try to solve all the problems. Okay, definitely you will get idea regarding the static friction. Okay, definitely once you solve all this question, no, whatever the question tell you based on that, you must answer. Okay, you are the position to answer all these questions. Okay, thanks for watching, children. Have a nice day. Bye, children.